Well, my take on it, first and foremost, is that was one of the stupid places to put 4 nuclear reactors there is in the whole of Japan.
So today we're joined by Dr. Patrick Moore, who is a co-founder of Greenpeace and also ecologist. He's been doing so many things in his life. One of the things has been building houses as well, but that's not what we're having him today. Hello, Patrick.
Hello, Christian. It's very nice to be with you.
The one thing that I've been asked all the time is, well, for sure, Fukushima is only 250 kilometers away. For sure, Tokyo must have been affected somehow. And the latest thing that I get as a response when I say I'm from here, it's the recent so-called, I have to put quotes on this, the contaminated water that was discarded recently by Japan. That's the water that it was used to cool down these reactors that are still up there and heating in Fukushima plant. And they've been using the water to cool it down. And then this water was stored in thousands of these huge tanks. And then I actually read the papers put out by the TIPCO. And honestly, at the end of when you finish reading, it feels like, well, doesn't really look that bad. But then you have all this reaction by people. They are so mistrustful. I mean, I guess there might be some reasons why you would mistrust the government given so many false alarms. But what is your take on this?
Well, my take on it, first and foremost, is that was one of the stupid places to put 4 nuclear reactors there is in the whole of Japan. They knew that tsunamis came there in the past, and it was only 8 feet above the sea level. In other words, about not even 3 meters. And so when that tsunami came, it shut down the reactors. The earthquake caused the reactors to shut down, automatic. And then the electricity from the outside, all nuclear plants also are tied into the grid.
Yeah.
So they can take electricity from the grid if they need it. But the grid was destroyed by the earthquake. So all they had left was the diesel generator, backup diesel generators. Every nuclear plant has those. But in this case, they were placed in front of the reactors towards the sea, and they weren't even nailed down. They weren't bolted to the ground. They were on skids. And the tanks with the fuel were on a hose, another skid. There were 2 of these. When the tsunami came 1 hour after the earthquake, everything was fine for that 1 hour because the generators were working. But the tsunami swept them up into the mountains and disconnected everything. And now there was no power. So therefore, the reactors melted, 3 of them. 1 of them wasn't operating at the time of the 4 that were in that group. And so now they're melting down. Well, when a reactor melts down, it creates very high heat, and the zirconium cladding that is around the nuclear fuel, it's like a pipe with nuclear fuel in it, begins to catalyze the water into hydrogen and oxygen to break it in half. The hydrogen then goes up because it's very light, and inside these big containment areas they're really just to keep the weather off. They're not meant to stop nuclear reactors from blowing up. That's down below in the ground. These are the General Electric style reactors, which are different than the Westinghouse, which are the 2 main prototypes for most of the nuclear reactors in the world. The GE one is more underground, but it has this big glass containment to keep the rain off it in particular. And so the hydrogen comes up and begins to build up inside these structures. And the operator phoned the prime minister and asked him if he could let the air out like they did at 3 Mile Island. Because as soon as the hydrogen reaches 8%, any spark will make a massive explosion and go right down into the reactor and damage it even further than it was in the first place. And the president said, no, you may not do that. Whereas in most countries, the reactor operator tells the president what he is doing rather than asking him for permission. But Japan has a much more sort of hierarchical power structure than many other countries.
I have to say, I just want to interrupt you there because I saw it was a PBS documentary. I can't remember, but that where the president, the prime minister of the time, he said that he actually, well, I don't know if that was trying to, not to get blamed for it, but he said that he actually said yes to the opening of the valve. Now, from what I know, is that they had a problem opening the actual valve. So
Well, no, this wasn't an issue of a valve. It was an issue of breaking a hole into the containment structure around this protect. Right. All they had to do was break the glass, and then the gases would come out, which is what they did at 3 Mile Island, only it was a concrete dome. But they did let the hydrogen out so that it wouldn't blow up. Whereas in Japan, they didn't do that. And then, even though no one was killed by the reactor accident itself, 2 men were killed by the tsunami when it came and drowned them. And then after the whole thing was almost over, the government decided to evacuate the people from the area, even though the radiation was not enough to be worried about. And it maybe stop growing food there for a while, well, especially till the iodine all decays. It goes away quite quickly. And it's one of the more dangerous radioactive isotopes that come with this kind of explosion. But what they did was they evacuated 7 intensive care wards where people were on ventilators and getting medicine from machines and everything. 2,000 people that they evacuated died unnecessarily. 2,000, because they took them out of the emergency hospital. And again, so there were 3 stupid decisions that were made during Fukushima. And if those decisions had not been made, it would have been fine. If the pumps were in a place where the tsunami wouldn't wash them away, like underground in a bunker up higher in elevation with wires coming down in the underground, that would have worked. But
that's exactly what they're doing now to upgrade the other nuclear reactors after the accident. That's exactly what they're doing, putting the generators up on a high places. Yes.
Very good. Well, at least we learn from our mistakes.
Yes.
At least some of the time.
But I'm curious, what do you think about because that's been a lot of, especially with China. I think that's mostly political, the recent contaminated, so to speak, contaminated water. I mean, there is tritium in there. There's one of these isotopes, but the way they've done it, patently, they have added so much water that the percentage of these isotopes inside this so-called contaminated water, it's so small that they claim, again, the people, there's also an international panel of scientists doing their study on this, if this is properly done. But the claim is that even if you throw this water in the ocean, and they would have no effect whatsoever on the fish. Is there any danger, like actual danger, in terms of for humans, like when we eat the fish, can we feel safe that is even if it comes from an area that it might be under that touch that water?
Yes, it is safe in the levels that they are. You see, some people think that all radiation is bad, right? But no, there's lots of medical procedures that involve using radiation to cure cancer, etc. So the problem happened early on when the environmental movement, and I was there, decided that nuclear weapons and nuclear energy should be put in the same box, right? So they basically demonized nuclear energy. And also the problem is, I mean, the title of my book is Fake Invisible Catastrophes. Radiation is invisible. So no one can actually see what it is doing. So there you can make up stories. And in medicine, for example, the primary rule is do no harm. Make people better, don't make them worse. And in toxicology, the primary message is the poison is in the dose. And all you have to do is look at table salt, sodium chloride. Chlorine as an element is very poisonous, very toxic, because it's radical in its chemistry. But when you combine it with sodium, you make salt. And salt is an essential nutrient. This is why Gandhi marched to the sea to make salt, because the British were taxing the poor people in China for something they needed. So they had to buy it. And so they took advantage of that. And so, but if you were to take a cup of salt and drink it with water, you would die, because at that level it will dehydrate your whole system. So that is how so many things work. Many substances are essential at low levels. Then you come to a place where it's not really, you're already getting enough, but a little more wouldn't hurt you. And then you come to a place where it will hurt you. So that if it does have toxic properties, I mean, water isn't toxic no matter what. You can drown in water, but it's not because it's toxic. And so there's many substances that are simply not toxic, but if you get too much of it, it can have other effects on you. It's not toxicity, it's actually drowning and making it so you can't get any oxygen inside yourself.
So why would China block the import of fish from Japan? In a world where this is should be common knowledge, why would such a thing happen? Like why would a whole nation decide that their citizens are not allowed to eat fishes coming from Japan?
Because of history, the Chinese don't like the Japanese invading them in World War II. And, this is all through history. These, I guess, prejudices are expressed, and they use a false reason for doing it, because and that's just a fact.
But the people believe it. We had, as one of the things that I do, also organizing these groups coming to Japan. We had a big groups from Malaysia that they decided to cancel after the release of the Fukushima waters into the ocean. So that's how it scares people so much. Like what you say in the book, like things that are invisible, things that you cannot reach, they are just too far away. They are really scary.
Well, it's easy to make up a scare story about something that is either invisible or so remote. That's why I use the example of polar bears and coral reefs. One is in the coldest climate in the world. Well, Antarctic is actually colder. There are only penguins, not even any polar bears there. But it is the coldest in the northern hemisphere, where the polar bears come, and it's the warmest at the Coral Triangle in Indonesia, where the most corals are growing. And they say if it gets any warmer, that the corals will die. No, they will expand into the warmer waters, because the corals, and then they say that the islands in the tropics will be flooded by the rising sea. The sea has risen up and down 40 times, 300 feet and 400 feet, or 100 meters. And every time the sea goes up and down during the glacial maximums and the interglacial periods, of which there have been at least 40 in the Pleistocene Ice Age, which we happen to still be in. This is the Pleistocene Ice Age, and people are saying it's too hot, even though both poles are covered in massive sheets of ice. Not just in the winter, but even in the summer, they're covered in massive sheets of ice. That is called an ice age. And this one is 2.5 million years already. There was one in the past that was 100 million years ice age. From 350 to 250 million years ago, there was an ice age just like the one we have now. So there are three things you need to know that this whole thing about the climate change disaster or catastrophe or emergency is false. First, it is not too hot now. It is one of the coldest periods in the history of the Earth. That's why there's all that ice on the poles, which it wasn't there for 150 million years before this ice age. There was no ice anywhere on this Earth because it was warmer, much warmer than it is today. Second, CO2 is lower now. in the atmosphere than it has been throughout nearly the entire history of the Earth. It's right now it's at 420. During the most recent glacial maximum, it went down to 180 parts per million, which is not far above the death of plants, because plants don't just need CO2, they need a certain concentration of it. And even at 420, it is still nowhere near the optimum level for plants. It should be 800, 1200, and then you start getting a much lusher vegetation all over the world. And already the greening of the earth as a result of our emissions of CO2 is 30% increased growth in the lush areas in the world. And the third thing you need to know is that all the CO2 that we are putting into the atmosphere, where did it come from? How did it get in the fossil fuels? By plants pulling it out of the atmosphere and the oceans. The plankton in the sea, the vegetation on the land, turned into coal, oil, and gas, and were lost from the air and the oceans. So all we're doing is replacing carbon dioxide, and anybody who calls it carbon, then I know they are not any scientific. It's not carbon, it's carbon dioxide, which is a completely different thing from carbon, which is soot, black soot, and diamonds and graphite. Carbon is a miraculous element because it has so many different forms. And yet, but carbon dioxide is the one that we need to have in the air and water so that plants will grow and that can feed the animals. Otherwise, if there wasn't enough CO2 for the plants, we would all die too, because in the final analysis, plants are the bottom of the food chain. And so how can people be worried about putting CO2 back into the air and water, which was there in the first place? There's nowhere else it could have come from. It didn't come from Mars. It didn't come from the rocks. It came from the air and water where it was much higher. And now we are replenishing the CO2 to a much better level than it had gone down to. We are the actual salvation of life on Earth. No other species could have done what we have done by burning the fossil fuels for energy, and also by using limestone to make cement, concrete. Limestone was made by life. It is the shells of sea creatures for 500 million years, going on to the bottom of the ocean and turning into rocks. Limestone, chalk, and marble are all of life origin. They didn't come from a volcano like granite and other rocks did. They came from life. And actually, most of the carbon that has been removed from the atmosphere and the oceans, especially from the oceans, but the oceans and the atmosphere are in equilibrium with each other, with CO2. If there's more CO2 in the oceans, more goes into the atmosphere. If there's more in the atmosphere, more goes into the ocean. So there's a law actually called, I forget its name now, but it's a physics law that gives the formula for the equilibrium between CO2 in air and water. And it's just air and water are in motion. They are mixing all the time, whereas the rocks are not. So when the shells of clams and mussels and shrimp and everything else which has a shell in the ocean, which is most of the, there are the chordates, which are the animals like us with a spine. You notice that we can move pretty fast, because we're pretty easy to eat if they get us, right? Whoever's trying to eat us, but we can move. Whereas a clam, it doesn't have to move because it's got a shell that is very, very hard. And I don't know if you've seen the birds going up with a clam and dropping it on a rock. Right, yeah. And that's how they get them. But anyways, over the many, many millions of years, these shells have turned into stone, and they contain calcium carbonate. That's what the shells are made with. And the carbonate comes from carbon dioxide, whereas the calcium is coming from the land, flowing into the oceans, taking it there, along with all the other salts and minerals that are in the sea. And, you notice that the sea has much more abundant life in it than lakes do.
Mm-hmm.
That's because there's so many nutrients in the sea that have been washed there by the rivers. Whereas the rivers and the lakes are, first, they're slightly acidic, but still lots of life lives in them. This is why you know that the idea ocean acidification is a lie.
Mm-hmm.
The oceans can never get acidic because they have so much alkaline substance in them, especially from the calcium and the sodium and those elements. They make the ocean quite alkaline and much more suitable for life than the freshwater environments because there's not many nutrients in freshwater. It falls from the sky almost like as pure water has been. It's like as if you have distilled the water when it is in the atmosphere. Well, I don't think there is much logic behind all of this concern about the climate change.
Yeah.
There's no logic to it at all. We are now at the end of a 50 million year cooling period. There's a period 50 million years ago is called the Eocene thermal optimum. And optimum is a good word. It means it was nice and warm everywhere in the world, even on the poles. There was no ice. And like it's kind of ironic. If it wasn't for the ice age coming, there would be no polar bears.
Right.
Because polar bears evolved from the Eurasian brown bear, the one you have in Europe. And that when the ice came, some of the brown bears went out on the ice and realized they could hunt for seals. And over hundreds of thousands of years, they evolved into being a polar bear. They turned white because that's good camouflage on the ice. They are half again as big as a Eurasian bear because they have to pull a 300-pound to 150-kilo seal out of the ice to get it up on there where they can eat it. And also they have a different digestive system because they eat mostly meat and fat and not so much vegetation like most bears do. So there would be no polar bears if it didn't get cold. And so that's a good thing. But people act as though this is good for us to get cold. No, it's not. We are not descended from penguins or polar bears. We are descended from apes in the equator. And if it wasn't for fire, shelter, and clothing, we could never have come out of the equator.
Yes.
Even where my home is on the Tropic of Cancer in Baja, Mexico, a human being could not survive that winter there, even though it never freezes. Most people don't realize that a human being naked in the shade dies at 20 C from hypothermia because our bodies are 36 C inside. And if you don't have sun to warm you, like you're under a rock, and you have no clothes on, you die at 20 C. Whereas polar bears don't die at 20 C. They have no clothes, they have no shelter, right?
Yeah.
They have no fire. Whereas the Inuit people that live in the Arctic, they have a home made of ice, they have fire inside, and they have warm clothing from the animals. So that's how they could go there. Not that long ago. It was a very short time ago that human beings occupied the ice places. And in Antarctica, there is no human civilization there. There is only science laboratories to do exploration and things.
It's like Mars.
But in the Arctic, there's actually a society of Inuit people.
One more thing I wanted to ask you is the ongoing scare that it's especially fed on social media about the macroplastic. Now, I've seen some studies. Actually, there were Italian researchers that found this. Apparently, on media there was also a picture, but I don't know how accurate that was, of this microplastic discovered in some blood clot. And the assumption is if we keep drinking from plastic bottles and we would all get all these microplastics in our body, or maybe they're in the fishes as well.
It is 100% lie.
Okay.
Absolutely, totally. Our digestive system cannot ingest plastic through our colon or through our intestine into the blood. It's not possible. Plastic is a polymer, a long chain. When you ingest plastic, it goes straight out the other end of you.
Right.
It doesn't go into you at all. But besides which, they say, oh, plastic, it won't degrade for 2,000 years, right? And then they say it's turning into microplastic. A fish scientist went out into the Pacific where they say there's a Great Pacific Garbage Patch twice the size of Texas. It's a lie. It does not exist. There isn't even one as big as a house. Never mind twice the size of Texas. There are aerial satellite photographs of the Pacific Ocean which show there is no Pacific garbage patch. Okay, so then someone said to me, yes, but it's only the clear plastic. That's why you can't see it, right? Well, that's obviously stupid. The clear plastic doesn't come together. Then they say, oh, it's just beneath the surface, as if each piece of plastic has a buoyancy compensation device on it. Things usually either float or sink. Some things will be in the middle somewhere, but it's not possible for all the plastic to be in one place.
So it's not gonna get into our veins. That's what
no, not going to get into our veins. It's a complete lie. But because it's invisible, they can make up this lie. You know, one of the, on another subject, sort of, one of the good things about the evolution of the animals is the hole that stuff goes in is smaller than the hole that comes out, right? So things pass through you quite easily and you don't get plugged up. But the thing about microplastic, it is just completely fabricated, as is ocean acidification. There is no possibility that the oceans will become acidic. And even if they do, there are freshwater clams and mussels. Fresh water is acidic, and yet the shells of the clams and mussels are fine, right? You know, there's freshwater clams and mussels.
Yeah.
And so they just ignore that fact that fresh water is actually acidic, whereas the oceans can never become acidic because there isn't any acid in them to do that. They are mainly with alkaline substances, the salts in the ocean. So these stories that have been made, and you see in my book, I've got about 11 or 12 totally different subjects. Radiation, for example, from nuclear energy. They say it's going to kill all the children or whatever, and hardly anybody has ever been harmed by a nuclear reactor. Chernobyl is the only accident that killed people, and it was because they had a stupid design reactor that they allowed themselves to build. And it wasn't even during normal operations that accident happened. It was because they were doing an experiment and they told the operators to turn off the safety systems. And then it went bad. And most of the people who died from the fire in Chernobyl were the firefighters. Only 8 people died of thyroid, and that was because they weren't diagnosed early enough. But most of the people who died, which was a total of 86, I believe, most of them were fighting the fire for 10 days to try to put it out. And they were right on top of the reactor, like right there. So they got a lot of radiation.
But I'm curious, who benefits the stories? Like, for example, the plastic scare. You know what? Why would these stories even circulate in the first place?
These organizations now, like Greenpeace, are making hundreds of millions of dollars a year from this propaganda. Okay. Because people send money to them, right, thinking that they're helping to save the world. Right. You know, when in fact, they are taking us back to some age when all is superstition, right? It's like there was a time when humans threw virgins into volcanoes and burned witches, you know, and they actually thought they were doing something good. Yeah. And here these people have been brainwashed And much of the leadership knows they're lying. They do know this, but they're making a fortune from it. And they're distorting the whole economic system. Wind and solar energy, for example. They say it's renewable. The windmills aren't renewable. The solar panels aren't renewable. And you can't make electricity without them. You can't just go into the sun and get electricity. The sun isn't making electricity. The windmills are making the electricity with the energy from the wind, but that doesn't make them renewable. I've said many times, all the wind and solar technology, the actual structures, should have to be made with wind energy and solar energy, and see if you have any left over to do something else with. I doubt it. It's a complete ridiculous situation. The only way we can get rid of a lot of fossil fuel use, and I'm in favor of reducing fossil fuels, not because of CO2 or climate, but because they are precious. And they should only be used for things that can't be done with something else. And what's that something else? Nuclear energy. Everything that is stationary, in other words, doesn't move like a truck or a train or a boat or whatever, everything that is stationary can be run with nuclear energy, because you can get electricity from and use it. You can make heat, right? You can make light. And so all buildings, which are about 30 to 40% of all the energy used in the world, can be 100% run with nuclear energy. Then you have big ships. The Russian the Russian ice-breaking fleet, 6 big ships are all nuclear. And submarines go underwater for 2 months with 100 nuclear missiles running on nuclear energy. If you can do that, you can make an oil tanker or a cargo ship go with nuclear energy. So we could take all the shipping. Also, trains, the tracks can be electrified with nuclear energy because they are stationary, unlike the train. Heavy equipment like a big truck bringing iron ore out of a deep hole up to the top, we're probably not going to be using wind energy for that, right? But and you can't use nuclear for that, so we use fossil fuels. But we could easily, over a 50-year period, reduce fossil fuels by 50 to 75% with nuclear. There's no other technology that can do that and be reliable 24/7, right? The real problem with wind and solar is it's unpredictable. Well, you can be sure it's not going to work at night with solar, but with wind, it's even more unpredictable in a way, because you know at least there's a chance of getting electricity from the sun when there's not so many clouds. But as soon as the clouds come, and then the winter comes in the high latitudes where you have hardly any solar in the daytime because you have such a short daytime, and there's no logic being used on this. We are making ourselves less practical. And the word green, green is a color. It is not a science word. It is not a technology word. It is a color. It's like calling communists reds. You know, it's just they're not really red, because red is just a color. and so green, calling people green has no scientific meaning whatsoever.
Like
it only
organic.
has
Like organic. We see that in all products now, right? Organic this, organic that.
And everything that was made from life is organic.
Right.
Everything. And here you have GMOs as a perfect example. What's the bad thing in GMOs? Is it radiation? No. Is it some toxic chemical? No. As a matter of fact, it doesn't have a name. The bad thing in GMOs has no name.
They say in the future, somehow, because we haven't eaten so far, it will damage our health somehow.
Yeah, actually, almost there's no reason to make a bad GMO, right? The only reason to make a GMO is to enhance the the vitamins in it, or to make it better in some way, to grow faster, be resistant to insects, whatever. But you're not going to get people to buy something that's damaging them.
Yeah.
You know, it's, and just again, golden rice, 1 to 2 million children die every year by vitamin A deficiency because they only eat white rice. And 2 scientists in Europe made a genetically modified rice that has beta carotene in it by putting genes from corn. Do you think genes from corn are dangerous? Or just put the leaves of rice plants are green. That means they have lots of beta carotene, but nobody eats the leaves.
Right.
It's just unfortunate that the seed of the rice, which is eaten by most people in the tropical countries as their primary source of energy, starch, has no beta carotene. And millions of children have died as a result of that through the ages. And these people are making millions and millions of dollars denying those people something that can cure their nutrient deficiency. I spent 5 years fighting this campaign back in the mid, around 2013 through to 2015, 16, 17, around in there. I fought hard, and we campaigned in India, we campaigned in Pakistan, and in Philippines, and in Europe. All through Europe, we went to the Greenpeace offices and demonstrated with big banners saying Greenpeace is causing the death of children because they are against this new product which could save their lives. And it didn't work. Not one country has yet allowed golden rice. And most of the reasons for genetic modification is like insect resistance and better growth rates and things like that. But this is a humanitarian issue of these children dying in remote villages and slums all through the poor countries of Africa and Asia especially. And 2 million a year. It was the scientists that figured this out, why so many children are dying of diseases that otherwise people wouldn't die from, like diarrhea and that. It's because their immune system is compromised because they're not getting the beta carotene. And beta carotene is not toxic. It is an essential nutrient. And these people are campaigning and making money killing children. And that's the kind of reason why I left Greenpeace after 15 years. I was in the top committee of Greenpeace. At one point, I was the president. I was in the top committee of Greenpeace founding group in Vancouver for 15 years. And in the final analysis, they decided that humans were the enemies of nature. The whole movement decided, okay, the only bad species is people. Oh yeah, right. You know, like vermin are okay, rats are okay, but humans are not. You know, just a minute here. The diseases are all okay. They're not evil like humans. And so that to me was like, you know, original sin, that we're born evil. Well, that was one thing, which is kind of a big philosophical point. But the thing that made me leave Greenpeace was when they decided, my fellow directors, none of whom had any formal science education, they were all political activists and things like that. And I guess I could be called a political activist, but I was an ecologist too, and I understood nature. And they decided that Greenpeace should have a campaign to ban chlorine worldwide. And of course, chlorine was used as a weapon in World War I by the Germans, and so it can be very toxic. But when it's made into salt, it's not toxic, it's an essential nutrient. And when chlorine was added to swimming pools and drinking water, it was the biggest advance in the history of public health. And if you look at our medicines, 85% of them are made with chlorine chemistry, and 25% of them have chlorine in them. And they were going to ban chlorine worldwide. So as a scientist who understood this issue, I just couldn't stay there. I had to write a letter and say, sorry, I had a good 15 years here, but you guys are crazy. And I'm going, so I then dubbed myself the Sensible Environmentalist, using logic and science to come to conclusions rather than misinformation, sensationalism, and fear. And that is what the environmental movement today, the radical environmental movement today, that is what they are. They are using fear, sensationalism, and lies to scare the people into thinking that what they are doing is bad for the earth or bad for the people, when in fact, we're so much more sophisticated now in understanding chemistry, understanding genetics, understanding the Earth system. And one thing you have to understand about the Earth system, the climate that is it is so complicated and has so many factors, most of which are non-linear, on top of which they are all in different cycles, overlapping and with each other. And then there's the issue of chaos. Chaotic. The climate is chaotic. The word chaotic actually means you can't predict it. That's the only way they can predict the weather is by having balloons go up and have boats go out, and they see it coming, so they can predict it.
Yeah.
They can't predict it for 6 months from now.
Yes.
Never mind 60 years.
No, let's close on this. It reminds me of a story. I met this this Hong Kong person who's I met him in a sauna here in Japan, and we were talking about. So, well, you know, he works in a bank, but also does riding for you know, in Hong Kong it's very big for horse racing. So I was like, so tell me about horse racing. I said, well, you know, I ride by horse. Well, how do you guys, you know, say? Well, we kind of know how to, you know, bet on the horse that could potentially win. I said, how do you do that? Well, basically, we just look on the last few runs that they had, and the ones who won the most. That's what we bet on. But we still miss them most of the time. So, you know, even a horse racing, you get a few horses, you still don't get it with all the science that goes into it. But we pretend to, you know, be able to describe the climate 50 years from now. Yeah, it's a bit.
Well, one way I put it is the crystal ball is a mythical object.
Yes.
It isn't a real thing, and neither is a computer model a real thing. It, you know, that early on, I was at the beginning of computers when I was at university, and very early, the expression "garbage in, garbage out" became known.
Right.
But it's true. If you don't know, well, you can't know the future of the climate. That's the whole thing. Nobody could know that. We can see the past of the climate, and from that we can gain great insight into how the climate works. But there's so many things that we don't know about why the climate changes the way it does. I mean, Jupiter's gravitational field affects the tilt of the Earth, the orbit of the Earth, and the wobble of the Earth. Jupiter's gravitational effect, that's the Milankovitch cycles, and they were discovered in the 1920s, and now we understand how they work. But for thousands of years, no one knew that. And there's so much that we don't know now. And the two things I think we will never know is, how did life begin? What was the mechanism for life to begin? We can never know that. And are we the only planet in the universe with intelligent life? In other words, life that could learn to make technology and communicate with the other planets. We don't hear them. We are a young star. There's other stars like the sun that are billions more years old. And so it is possible that this is the only place in the universe. Well, then you start talking about the universe. Does it end somewhere? Because they say it was a big bang and it's expanding. Expanding into what? Into nothingness? How much nothingness is there? You know, these questions are beyond this. Maybe 20,000 years from now, intelligence will get better, but
we'll get enough 20,000 years from now.
It's not very long in geological terms. 20,000 years is like that.
Sure.
And that's what people don't understand is how long it took for this situation where actual human beings are talking to each other over electronic devices. It took 3.5 billion years for that to happen. And what will happen in the next 3.5 billion years? I forget when it is when the sun is going to get too big and engulf the earth.
Yeah.
Apparently that will happen, but it's some billions of years from now. So we don't have to worry too much. The same thing with the next glacial maximum, which we are already sliding into, just beginning the first 5,000 years of a 75,000 year decline. Because when the Earth cools, it cools very, very slowly during an ice age like this, when it cools back down to where it's even colder. And then it comes up quite quickly in only 10,000 years. And then there's a 10,000 year period of interglacial, which we are in now. But it's still way colder than it was for the last 150,000 years were warmer than it is now. And so, so we don't have to worry about the fact that 70,000 years from now, the ice will come and cover all of Canada and all of Europe again, and half of Russia.
We might be on
That's
Mars by that time. When people are building ships for that.
not going to happen.
Not gonna happen.
There's nothing there that we need. And especially there's no atmosphere there. We need an atmosphere. So we'd have to build bubbles. And then we'd have to get the gases there. It's the only thing that will happen is someone will land on Mars and declare victory and come home. Right? That's all that will happen.
You're
There
skeptical
will
about
not
the
be
life
cities
on
on Mars.
Mars.
Of course I am. The environment is completely inhospitable. It would be like so cold, no air, no water. How nothing can live in that. And the idea that there was life on Mars before is only to get money. They've never found any indication whatsoever that there was ever life on Mars. It's a total scam. And I don't know why Elon Musk is so, I mean, I guess it's just for ego. You can do this or to make a mark. You know, if he could go there and come back, he would be the first person who did it. But once you come back, you're not going to go there again. There's nothing there.
Right. Well, his idea is mostly like people, if you go, you're not going to want to go back anyway.
No, you would not. You want to come back to the Earth. That's what you'll want to do.
You know, I've seen the people wanting to participate. I think it was an online something that they were organizing for gathering people who were willing to go on Mars with the first ships or the others. And I went there, and I think I applied even. But anyway, I went and I saw all these hundreds of people from all over the world. They're just willing to go, you know, even taking the risk of their own lives, because, you know, that's Musk is actually pretty straightforward about it. He's, you know, like the first trips are not going to be that safe. But to me, it was surprising to see how many people were still willing to just go and probably would never come back. That was interesting, though.
That's right. And as soon as it's found out that they never came back, there won't be quite as many volunteers the next time.
Right. As soon as they well, it's been a pleasure talking to you, Patrick. If anybody wants to read his books, we'll put a link below on the comment sections. And so thank you so much for sharing your knowledge with us.
Thank you, Christian. It's been a pleasure. And enjoy your life in Japan. It must be a very interesting experience for you.
It is. Thank you very much. Thank you.